Hi, I'm Sarah Norman, and today I'm presenting Prescription Filling Among Medicare Beneficiaries with Depression, Evidence of Medication Adherence Issues. My SQL analysis of the CMS Synthetic Claims Database, focusing on prescription trends and how they vary across different patient groups. Why should we care? Research from 2008 to 2010 showed that patients with depression were almost 2 times more likely to be non-adherent to their medications compared to patients without depression. When we were given the CMS synthetic database to use for the final project, it gave me the opportunity to analyze Medicare prescription data from the same time period to see if there were patterns that might indicate medication management challenges in patients with depression. My first query compared basic prescription metrics between patients flagged with depression versus those without. The SQL code uses a case statement to create patient groups, then calculates averages and counts. What's interesting here is the trend showing patients with depression have shorter days supply while filling a higher number of prescriptions. My interpretation of this: patients with depression average shorter days supply of medication and fill significantly more prescriptions per patient. Shorter days supply of medication plus more prescriptions to manage equals opportunity for medication adherence issues. Next, I added age categories to see how distributions change across demographics. The query builds on the previous one, but adds age brackets using case statements. The results show patients with depression concentrated in older age groups with notably higher prescription counts per patient in each bracket. My interpretation of this: patients with depression are primarily over 65. They average a higher days supply of medications, but fill significantly more prescriptions per patient. Increased age plus more prescriptions to manage equals opportunity for medication adherence issues. For gender analysis, I added another grouping variable. The results show patients with depression as primarily male in this population, with the same trend of higher prescription fills across both genders. My interpretation of this: patients with depression are primarily male. They average a higher days supply of medications, but fill more prescriptions per patient. Gender appears to impact number of prescriptions and days supply of medication. Here, I categorize days supply into ranges to examine distribution differences. The query creates supply categories and counts prescriptions in each. The findings show both groups clustering in medium-term supplies, but patients with depression still have higher overall prescription fills. My interpretation of this: patients with depression are mostly prescribed 30 to 60 days supply of medication, but still fill significantly more prescriptions per patient. Consistent supply of medications, but frequent prescription fills equals opportunity for medication adherence issues. Adding comorbidity flags allowed me to examine more complex relationships. This query joins multiple diagnosis indicators. The trends show more scattered supply distributions when comorbidities are present. My interpretation of this: patients with diabetes and depression have varied days supply of medications. Patients without depression are primarily prescribed 30 to 60 days supply of medication. Depression plus an inconsistent supply of medications equals opportunity for medication adherence issues. I used a similar approach with heart failure flags. Interestingly, the results show more consistent distributions across both groups when this diagnosis is present, suggesting different underlying trends for certain comorbidities. My interpretation of this: patients with congestive heart failure are primarily prescribed 30 to 60 days of medication. Depression does not appear to have an impact on supply frequency in patients with this diagnosis. The trend continues with ischemic heart disease. Both groups display similar supply distributions, which show how different comorbidities create varying results in the data. My interpretation of this: patients with ischemic heart disease are primarily prescribed 30 to 60 days supply of medication. Depression does not appear to have an impact on supply frequency in patients with this diagnosis. With Alzheimer's flags, we see that scattered variation return. This demonstrates how different diagnoses affect prescription fills. My interpretation of this: patients with Alzheimer's disease have varied days' supply of medications. Patients without Alzheimer's disease are primarily prescribed 30 to 60 days supply of medication. Alzheimer's disease plus inconsistent supply of medications equals opportunity for medication adherence issues. For a seasonal analysis, I extracted months from service dates and categorized them into seasons. The results show consistent elevation in prescription counts for patients with depression across all seasons, not seasonal variations. My interpretation of this: patients with depression fill significantly more prescriptions than patients without depression throughout the year. Change of season has minimal impact on number of prescription fills per patient. Finally, examining prescription averages by age shows an inverse relationship. Higher counts for younger elderly patients that decrease with age. My interpretation of this: younger elderly patients in the age group of 65 to 74 with depression have a higher average number of prescriptions than older elderly patients in the age groups of 75 to 84 and 85 plus with depression. Does the data agree? This analysis included both targeted queries addressing depression and medication adherence, as well as queries examining other patterns in the synthetic data set. This is a good example of how database analysis projects often require exploring different associations than originally expected when working within the constraints of available data. Overall, this synthetic data set demonstrates consistent trends of higher prescription fills for patients with depression across multiple demographic and clinical variables. While these are simulated findings rather than real clinical insights, it provided excellent practice with complex SQL analysis techniques.